Hello dear learners, welcome back to Fun Scholar e-learning series. I am Rikta and we here at Fun Scholar are committed to bring the best from the world of robotics and electronics to you. Hope you remember in the previous tutorial we have learned about breadboard and how to connect different electronic components onto it. The link of the previous tutorial is in the description box. You can also watch it out just by clicking on the link popping up at the right top side of your screen right now. By the time, don't forget to like, share and subscribe to our YouTube channel for more such interesting tutorials. Today we are going to learn about diode. The topics which we are covering today are: what is actually a diode, how does it look, what are the two terminals and its symbol, the direction of flow of current through it, what is actually a semiconductor and the difference between a conductor, semiconductor and insulator, the concept of p-type and n-type semiconductor and how the depletion region forms, the working of the diode under forward bias and reverse bias. And at the end of the tutorial there will be a pro tip for all of you. So do watch the tutorial till the end to get that tip. Let's start today's video. Today we are going to learn about diode. What is actually a diode? It is actually a semiconductor device having two terminals and allows flow of current through it only in one direction. It looks something like a cylindrical body having a stripe at one end and two leads coming out from both the terminals of it. Through this lead we can connect it into any circuit. This is the symbol of a diode, where this straight line indicates the negative terminal and the other terminal is the positive terminal, which is called the anode, and the negative terminal is called the cathode. As the diode works as an unidirectional switch, so it's allows flow of current through it only in one direction, that is from its positive terminal to the negative terminal. In the opposite direction, that is from negative to positive, there will be no flow of current through the diode. Diode is actually a semiconductor material. So let us first understand what actually a semiconductor is. A semiconductor is a material which has electrical conductivity in between a conductor and an insulator. A conductor is a material which allows the flow of current through it, whereas the insulator is just opposite of it, that is, it doesn't allow any flow of current through it. Now what is the difference between an insulator, a semiconductor and a conductor? The difference is in the length of the band gap of valence band and conduction band. Now what is valence band and what is conduction band? The valence band is the band of energy level of valence electrons and the band of energy level of free electrons are called the conduction band. In case of insulator, the difference between the valence band and the conduction band is much more, so that the valence electrons in the valence band couldn't get that amount of energy to jump from valence band to the conduction band. That is the reason there is no free electron in the conduction band, and because of this the insulator cannot allow any flow of current through it. Whereas in case of the conductor, there is no gap between valence band and conduction band. The valence electrons in the valence band can easily jump from valence band and conduction band and become the free electrons and constitute the flow of current. Whereas in case of semiconductor, the gap between valence band and conduction band is small. So if the valence electrons in the valence band can get sufficient amount of energy, then they can jump from valence band to conduction band and become the free electrons and constitute the flow of current. But if the valence band, the electrons in the valence band couldn't get that amount of energy, then there will be no flow of current through it. So at this time the semiconductor works as an insulator. Now what is a p-type and an n-type semiconductor? A p-type semiconductor is one where the majority of the charge carriers are the holes that is the positive charge carriers, whereas in case of n-type semiconductor, the majority of the charge carriers are electrons, that is the negative charge carriers. When these two type of semiconductors combine together, then as the p-type semiconductor has majority of the charge carriers, that is the positive charge carriers, and the n-type semiconductor has negative charge carriers, so there will be a potential difference between these two. Because of this high potential difference, the positive charges from the p region want to go to this n region and starts recombine with these electrons, as well as the electrons in the n region starts to flowing in this direction and starts recombine with the holes. This process of recombination is called the diffusion. Because of this diffusion, a layer of positive charges will be created near the n-type semiconductor and a layer of negative charges will be created near the p-type semiconductor. Because of this layer, which is called the potential barrier, further diffusion will not be allowed. This region is called the depletion region. This depletion region doesn't allow the positive charges of the p-type semiconductor as well as negative charges of the n-type semiconductor to diffuse with each other. When we connect the diode in forward bias, that is the p-type semiconductor is connected to the positive terminal of the voltage source and n-type semiconductor will be connected to the negative terminal of the voltage source, then this positive terminal will repel the positive charge carriers of the p-type semiconductor and push them in this direction, whereas this negative terminal of the voltage source will repel the negative charges of the n-type semiconductor and push them in this direction. Because of this, the length of the depletion region starts decreasing, and at a certain level of voltage, for silicon which is 0.7 volt and for germanium that level of voltage is 0.3 volt. The silicon and the germanium are the two different type of materials which we generally use to make the semiconductors. If we apply a voltage which is more than either 0.7 volt for silicon or 0.3 volt for germanium, then at this level of voltage, the depletion region starts decreasing and becomes zero, and there will be a flow of current through the diode from the positive terminal of the battery to the negative terminal of the battery. So under this forward bias condition, there will be a huge flow of current through the diode as the depletion region becomes zero at a certain level of voltage. When we connect the diode in reverse bias, that is the p-type semiconductor is connected to the negative terminal and n-type semiconductor will be connected to the positive terminal of the voltage source, then the positive charge carriers of the p-type semiconductor will be attracted towards this negative terminal and the negative charges of this n-type semiconductor will be attracted towards this positive terminal. And because of this, the width of the depletion region will increase. As the depletion region increases, so there will be no flow of current through the diode. So under reverse bias condition, a diode doesn't allow any flow of current through it. Now this is the time to get the pro tip. As I have already told you that a diode looks something like a cylindrical body having a stripe at one end. So by looking at this, how will you be able to understand which one is its positive terminal and which one is its negative terminal? The terminal which have the stripe is the negative terminal of the diode and the other terminal is the positive terminal. Always remember that in the symbol this straight line is actually the stripe. So this is your negative terminal and this is your positive terminal. Hope you like this tip. For more such tip and tutorial, don't forget to subscribe to our channel and do like and share with your friends. In the next tutorial, we are going to learn about another very important electronic component, which is a transistor. Till then, keep learning, keep watching Fun Scholar e-learning series, and please be safe. Thanks to all of you.